Hey everyone, I'm Suresh. I'm the General Manager for Amazon Relational Database Service. I hope you've been having a fantastic and productive week so far at re:Invent, and thank you all for coming to this session. Over the next 60 minutes, I'm going to talk through some of the major capabilities that we've introduced in RDS this year. It's a 300-level talk, so assume that you know what RDS is, perhaps you even use it, but not necessarily that you know how it works under the hood. And that's a little bit of what we'll get into today. To level set, RDS is a fully managed database service that makes it easy to set up, operate, and scale relational databases in the cloud. We offer customers a wide choice of databases, including cloud-native Amazon Aurora, 3 open-source databases, and as of this week, we're excited to say 3 commercial databases, including DB2, which is our newest. And for customers who bring these databases to RDS, what's our core value proposition? The main thing is simplicity. Customers come to us because it's simpler than self-managing your database, whether on-premises or even in the cloud. And so the first thing that we look for is, are we doing what we need to do in terms of making it easy to develop on RDS? For example, if you had a generative AI use case, what are we doing to help make it easier for you? The second thing is, are we making it easy to operate and administer a database in the cloud? Right? And this is a big part of what we do. We offload the undifferentiated heavy lifting associated with operating databases in the cloud. Backups, patching, all that stuff. So that's the core value prop. But in our quest for simplicity, we also want to make sure that we're consistently hitting and improving and raising the bar on the core things that anyone looks for, you, us, when you're operating a transactional database. Any mission-critical database has to be up, right? So availability, and goes without saying, you can't have data loss, and durability are paramount. We also focus a lot on performance and scale for 2 reasons. As your business grows and as your workloads grow, we want you to have confidence that RDS's headroom is also growing, right, as our ceiling grows. And second, frankly, we want to deliver better price performance every single year so that you can do more with less. And then last, but definitely not the least, security and compliance. Almost goes without saying, data and security, 2 peas in a pod, right? You have to have secure data for your enterprise workloads. And then compliance is critical because you need compliance both for your own internal business operations, but also you may have products where your customers expect specific compliance of you. So that, in a nutshell, is RDS. And so when we think about what are we going to deliver for our customers, and most of this comes from conversations with customers such as yourself, whether at re:Invent or through the year, we look at innovating across these 6 different dimensions. Increasing customer choice. We want to earn your business every day through choice. And simplicity, availability, durability, performance scale, and secure and compliance. So let's get right to it. We're going to organize our conversation today along these different dimensions, starting with customer choice. So as I just mentioned, very excited to say that we now support our 8th engine in RDS. It's IBM DB2. And the value proposition is the same as you'd get with any of the other RDS engines. Easy to set up, operate, and scale DB2 in the cloud. So we offload all the undifferentiated heavy lifting. We make it easy. Within minutes, you can set up a multi-AZ environment for your mission-critical workloads. And the important part here is it's bit for bit the same binary you'd get, DB2 binary you'd get, if you're operating it as self-managed on premises or on EC2. And the reason this matters is it's very easy to lift and shift onto RDS. So that's what we offer. Now, how do you actually use it? Again, same experiences today with any other RDS engine. You provision on the console within minutes. You can bring your own database. You can migrate an existing workload, either using AWS Database Migration Service, or you can use any of IBM's excellent native migration tools. And then last thing, you can bring your own license. This matters because many of the customers we spoke to who asked us to support DB2 in RDS said, we have a fantastic relationship with IBM. Long-standing customers, we have advantageous pricing with them. We don't want to give that up when we get to RDS. And so you bring your own license, and with that, any private pricing you have with IBM, you just operate the database in the cloud in RDS. So very excited about this, and if you use DB2, we hope that you'll consider RDS. But as exciting as launching new engines is, it's just the start. In Amazon, we have the saying, it's always day one. And by that mean we're all innovating, right? It doesn't stop with a launch. And so for the existing engines we have, a very important part of ensuring you have choice is to ensure that we are giving you the latest from the third party, whether it's an open source database or whether it's a commercial database. So in the last year, we've added support for 4 new major versions: Postgres 16, MySQL 8.1, which is a new type of release they call innovation releases, Maria 10.11, and SQL Server 22. All 4 have important features, whether it's fixes, performance improvements, security, you name it. The only thing I'd call out here is that over the last couple of years, AWS has significantly increased its code contributions for Postgres in particular. And so some of these, like logical replication, SIMD CPU acceleration, is work that we have done with the community. And the reason I call this out is, again, your feedback is vital to us. When you tell us what you need out of Postgres, we work with the community to make sure that it gets into the next major version release. So that's the second aspect of choice, to make sure that you have the latest engine versions, so you're never like, hey, can I stay in RDS and still get the latest and greatest, or do I have to go use something else? A third dimension of choice is around what happens when you have certain constraints that prevent you from using fully managed RDS, right? A couple of reasons this could happen. Maybe you want a customization of the database that we don't offer out of the box. Or second, you need an application that has elevated privileges, which again, we don't support. And so for these use cases, which are more common with commercial applications, especially those that run on SQL Server and Oracle, we provided a new deployment model that we call custom. So RDS Custom gets you the full automation that you'd expect from RDS. All the stuff that we offload off your hands, the undifferentiated heavy lifting, you still get that, except now you get it in an instance that you own. It's a customer-owned EC2 instance. It's been very compelling for customers. Customers use it to bring their own applications that they couldn't otherwise run on RDS. And 3 new announcements this year. The first is for SQL Server. It's now possible to bring your own license to RDS. Previously wasn't possible with fully managed databases. Same benefits as with DB2. If you have advantageous pricing, or if you want a specific binary that we don't support, like the developer edition, you can now bring it onto RDS. We also now support multi-AZ out of the box. So instead of having to wire your own on RDS Custom, you get it provisioned within minutes, just like with regular RDS. And in the case of RDS Custom for Oracle, you can now run e-business suite. There were a couple of things that we're missing. For example, the ability to configure your home directory and system ID. We've made those fixes. So if you have Oracle e-business suite and you want the benefits of a fully managed database, you can now use RDS Custom for Oracle. I'll go a little bit into detail on how you bring your own license and media into SQL Server. It's a slightly different workflow, so just want to make sure that we cover it. Step 1, you download the SQL Server binary. Step 2, you put it on an EC2 instance. And you would create an ARMY just the way you would with any other ARMY in AWS. Step 3, you register this, the engine version with RDS. This is all a one-time step. And once you're done with that, you can provision a database any number of times you want. We take care of the patching and all the other stuff. You just do a little bit of one-time work, fairly straightforward, and then you get to bring your own license into RDS. The last part around choice is the ability to come in and out of RDS as you please. We want you to use RDS because it's right for you, not because you have to. And for this, we support database migration. We have the AWS DBMS service. It supports 23 sources and targets, which is a lot. It gives you a lot of choice. And one of the ways we do this is by converting the source data into an intermediate format before then translating it to a target format. And this helps us because we don't have an n-squared problem. It's more of a linear problem when we add new sources, which is good for us, but frankly, it's got a few gaps. Right? You end up doing 2 copies sometimes when you don't need to do 2 copies. And there may be some gaps in terms of the data types that we support or the schemas that we support because you have to go through this common generic format. And so for that, AWS DMS now supports native tools when you're doing homogeneous migrations. So when you're going from MySQL to MySQL or Postgres to Postgres, you can now use tools under the covers like MySQL dump, PG dump, PG restore. Same workflows before, with one improvement, it's all serverless. DMS transparently uses native tools. It recognizes when the source and the target are the same engine, so you don't have to do anything. It's seamless. And the benefits, as I mentioned, is you get more complete functionality in your migration and improve performance. In the case that you're using Oracle, we now support Recovery Manager with transportable databases. So it's great in terms of being able to use physical migration, incremental backups, and restore, so more performant. And one thing to call out here is that you can put your files, your backup files, in an EFS file system, and you can attach that to RDS for Oracle now to make it easier to ship backups from your other environments into RDS. So that's on choice. Let's pivot a little bit to the next part, which is around simplicity, right? And we'll start with what we have done this year, especially in Postgres. Both of these topics are Postgres, to make it easier to build generative AI use cases. It's clearly the topic du jour, right? We've reached a tipping point this year. It's very clear. But from our perspective, it's actually the current latest iteration of a long set of innovation that's happened over the last 20, 30 years, right? A lot of work under the water. We sort of broke the surface, so it feels new, but it's actually a continuation of what's happened before. So if you look at classic machine learning, takes simple inputs like numeric data, converts it to numeric data, right? Predicting values. That's kind of historically what machine learning did. About 10 years ago, deep learning came on the scene. You could take complex data like images, and you could do things like search. You can mapping complex data into simple inputs. And the change with generative AI now is you take complex data as inputs, and you put out complex data as outputs, right? Draw me a picture of a cat, or write me a poem. And the technical leap that goes from deep learning into generative AI is based on something you've probably heard, right? Foundation models. And the key about foundation models is that it's trained on a vast amount of unstructured data, and it has many parameters. Think of parameters like the more parameters you have, the more learning concepts you can model. But here's the really key point. It can be applied in a wide range of contexts. And you do this through something called customization or fine-tuning. And this is where the magic is, right? Traditionally, if you had deep learning or traditional ML models, you build a different model for every specific domain that you care about. But here, you can start with the foundation model, spend a whole lot less effort to customize it, and voila, you have your app. So what would have previously taken weeks, months, now you can shrink it to days with a tremendous savings in your developer and data science productivity. But and Amazon Bedrock offers a number of these ML models, foundational models. Again, we're all about choice. We want you to be able to choose what's right for you. But as fantastic as foundation models are, they're not sufficient. So let's take an example. Let's say that you have a product catalog, blue elephant vase, and you want your customers to be able to search your product catalog using a chat-based application. Right? So how would you do this? If you just had the foundation model and nothing else, and you asked a question, which you can see under the question there, how much does a blue elephant vase cost? The model probably doesn't have an answer for you, right? Because it's trained on generic data, maybe off the internet. It doesn't know anything about your product catalog, your price points. So if you can augment this, and this is where something called retrieval augmented generation comes in. If you can augment this with your product catalog, with your pricing data, and you ask the question, now suddenly we're able to answer it. It costs $19.99, right? So let's click one level deeper and look under the hood and see how does this happen. So at its core, an important concept is called vector embeddings. So what we do in this case is you take your product catalog, you chunk it up, right? We call it tokenization, into smaller pieces, and you run those smaller pieces through the foundational model, and what comes out on the other side are these vector embeddings. So vector is nothing but a list of numbers, right, an ordered list. If it was a two-dimensional vector, you'd call it x and y axis. If it's 1,536 dimensions, same thing, it's just a much higher dimensional space. And the key is, in these higher dimensional spaces, the closer you are, when you're clustered, it's more similar. This is like the fundamental core concept, right? Similarity in a higher dimensional space. So let's bring it back to your example. You have this catalog application, right? So you have your catalog, you break it up, you put it through a foundational model, and what comes out is a bunch of embeddings, which you store in a database, and this, by the way, is a link to RDS. But that's a one-time thing, or maybe an infrequent thing, where you're updating your metadata. And the actual application, your user asks a question. The question itself is tokenized. You use the token, or you create a vector embedding out of it. You use that vector embedding to search what you've already stored in the database to find similar data, which then gives you not just the user's question, but also additional context that's specific to your enterprise, which then you run through an LLM, and then what comes out is a more specific answer, like, hey, this is $19.99. So this is the transactional part of it. And when you look at sort of the intersection of this, it's the vector store and database. So a question is, I mean, why is this a big deal, right? Turns out there's several challenges with storing vectors. So the first is it takes time to generate these vectors and to actually index them. Second is, if you're storing 1,536 numbers with every single column, that starts adding up, and you can't easily compress these things because they're mostly random numbers. And the third is the query time is actually complicated because, again, when you're trying to do a similarity search, it's not like you're comparing one number to one number. You're actually comparing 1,536 numbers on one side to 1,536 on the other side, right? And so it certainly takes longer than the animation. And so there's this concept of approximate nearest neighbor. And effectively, what you're doing is you're not looking for exact matches, but you're looking for stuff that's close enough. I mean, think of a search that you do on an internet search engine. You don't need all 50 pages. What you care is good enough answers in the first page. And that's kind of what this is, right? It's faster than getting the exact comprehensive list, and you get a share of the total results, which is what we call recall, right? So that's what you want out of the vector database. Fast builds, fast searches, and something that's also efficient from a data and cost perspective. So the question becomes, what do you use as your vector database, right? Do you create something bespoke, something like Pinecone, which we support through Bedrock? Again, we're all about choice. Or do you want it something in Postgres itself, as an example, or OpenSearch? Then you have to question how much data are you storing. What do you really care about? Is it the performance, or is it the latent relevance of the answers that comes, right? Speed or relevance. And then last, what kind of application do you have? Is your application more in sort of you're constantly updating your metadata, so you need better indexing, or is it very high throughput, so you favor query time and ability to iterate your app through new schema? One thing we hear from our customers a lot is, again, they want choice. What they want is the ability to use vectors within their existing workflows without having to go create something else, like a new vector database and having ETL set up. And that's where, for RDS for Postgres, PG Vector comes into the story. PG Vector is an open source extension that allows you to store, index, search vectors. It's co-located with your metadata, so it's easier to query. And it gives you a range of options in terms of distance vectors, things like cosine distance or Euclidean distance. It's fairly full-featured. When you use, as a builder, PG Vector and RDS Postgres, and it comes out of the box, a key decision you'll have to make is what kind of indexing scheme do you want to use. When PG Vector was launched, it had one version called IVF flat. After that, it added a second index type called HNSW. So what are these things, and why do you care as a builder? So with IVF flat, it's essentially organized as a list of vectors, and HNSW is more like a graphical model. So this has implications for performance in terms of recall, search performance. And then both of these, again, have different characteristics in terms of build. IVF flat requires you to have a pre-populated data, but HNSW is able to iteratively add more data, and it's also much faster in terms of searches. So as a builder, when you think about using PG Vector with RDS for Postgres, your choices are going to be between fast indexing. If that's your main priority, use IVF flat. But if you're interested in search and recall, higher performance for high recall, or ease of management, use HNSW. A couple of charts. On the left side, yellow is IVF flat. It's faster, lower is better. On the right side, higher is better, and HNSW wins on query throughput. But the most important thing here to note is this is a very rapidly moving space, so I wouldn't take anything as a fixed point in time. When we first introduced IVF flat, a lot of our customers said, hey, you have to be better in terms of search performance, so we worked with the maintainer to get HNSW in. When we did that, they said, this is great, but index speeds need to be faster, indexing speeds. So 0.5.1 is even faster. So very fast-moving space, and there's a lot more coming. So as a builder, how are you going to keep up with this? And this is, again, where one of the benefits of using a fully managed service is you don't have to think about it. Just stay current with the latest minor version of RDS for Postgres, and we will keep making sure that you get the latest and greatest in PG Vector. And it's not just the latest minor version, also stay current on your instance types. So we have an example here of Graviton 3 versus Graviton 2. Higher is better. Graviton 3 outperforms Graviton 3. So again, as a builder, if you're looking to build generative AI use cases, one of the reasons to consider using RDS for Postgres is you stay current without much work, so then you get to focus on the things that are specific to your business. So that's on generative AI. Switching gears a little bit, another thing a lot of our Postgres developers have asked is, hey, how do I get more flexibility in terms of innovating in and around RDS for Postgres, right? And so last year, we introduced something called trusted language extensions, which gives customers a lot of flexibility in the ways they can use Postgres. But let me just start with a recap of what extensions are. Extensions are a very powerful mechanism in Postgres that lets you take literally any part of the system, which has hooks, and alter the behavior. So PG Vector itself, as an example, is an extension. The reason this matters is that it allows you as a builder to iterate a whole lot faster than core Postgres does. Core Postgres releases a new major version every year. And frankly, if you're waiting a year to get a new index type into PG Vector, the world would just move faster, right? So you get a lot of speed, a lot of innovation by using extensions. But there are challenges, right? And the challenges is many of these are written in C. They require deep access into the system. And when you do a major version upgrade, it doesn't always work out of the box. And so for someone like us as a managed service provider, or for someone like you using a managed service, it becomes a little problematic because we don't want to give deep access to extensions because there could be security issues, stability issues. And then, of course, when we offer a new version, we want to make sure that it just works. Like, we don't want you to choose your own adventure, right? If you use an extension like PG Vector, the next major version that comes, it should just work. The way we have historically solved for this is we do a lot of the qualification ourselves, certification, and we support 90+ extensions. Works great, but the truth is there's thousands of extensions out there. And so that's what trusted language extensions is meant to solve, is to take away the dependency on RDS when you're a builder or a customer so that you can innovate faster than a new major version or a new minor version. So as a builder, you build an extension using the TLE framework, the Trusted Language Extensions framework. As a customer, you say, hey, I want to use it. As a DBA, you say, which extensions are my customers allowed to use versus not? Easy. Last year when we launched, we supported three of the trusted languages. These are the three most popular, except for C, which a lot of extensions are written in, again, for the reasons that C is not really a safe language. Our customer said, we love this framework, but we need something that's faster. And so we now support PL Rust. It's fast and safe. And when we ran a test, this is an example of normalizing, I think it was 100,000 vectors, 768 dimension vectors. The PL Rust implementation is between 4 and 17x faster than the alternatives. So that's on making it simpler to develop with RDS as a builder. What about the operational side of this? As I mentioned earlier, a big part of what we want to do for you is offload the undifferentiated heavy lifting associated with running a database. It's all the stuff on the right. We want to take it off your hands so you can focus on the left, schema design, query construction, query optimization, that's more specific to your business. And our customers love this, right? A lot of customers use RDS. And on something like updates, we provide one-click updates. But our customers have said, hey, as good as this is, it's still, it's causes trepidation every time a customer updates. And why is that? First, there's downtime, right? No one likes to take downtime. You want to be in business 24/7. And the second thing is, if it's a major version upgrade, you have to qualify your application because the new major version of a database may or may not work exactly the same as before, right? And so that's a heavy investment of your resources to make sure that it works with the new major version of the database. So excited to announce 3 new improvements we've made this year. The first is extended version support for Postgres and MySQL. We now support both of these databases 3 years past community end of life. And so if you are a customer that loves your application and loves your major version of Postgres and MySQL and just don't see a reason to move, we will help you stay on it and make sure that you're getting all the critical patches for CVEs, any major bug fixes. You will be covered under our SLA. You'll have the multi-AZ support, everything that you'd expect. And this essentially gives you 3 additional years where on your time you can figure out when you're going to qualify for the next major version. So that's one. But what if you're doing a minor version upgrade? These come more frequently, and they're really a good idea to apply because they often have security patches. In the case of multi-AZ DB clusters, which again is available for MySQL and Postgres, we've made a major innovation. which is to support 1-second rolling upgrades. So how do we do this? Let me tell you a little bit about what multi-AZ DB clusters are, and then it'll make more sense. So essentially, for both Postgres and MySQL, we now have a clustered model of deployment across 3 AZs with 1 primary and 2 replicas, and they use native database replication under the covers. It's got lots of benefits. It's about 2x faster from a write throughput standpoint. You get readable replicas, so you can lower cost. It's faster from a failover perspective. It takes about 35 seconds versus, let's say, 1 minute to 2 minutes in the classic multi-AZ design. Customers love it. But in the context of upgrades, when you do an upgrade, we first upgrade the read replicas. During this time, your database is still available because your primary can still take both read and write workloads. Then you do the switchover. This is the period of unavailability. Now, if you use a proxy, and this proxy could be RDS proxy, it could be something like PG Bouncer, Proxy SQL, it could even be an advanced JDBC driver that knows how to handle DNS propagation. The downtime, the switchover, is less than a second, or typically around a second. This is the period of unavailability for a minor version upgrade with RDS for Postgres and MySQL when you use database clusters. And then once you switch, your old primary is now a replica. It's still running the old version. You got to go upgrade it. But then you could do that in a way where you're still available because your new primary is now running the new version. So this is also something we're very excited about. Our whole goal here is to make updates a non-event for you, so you do them more frequently and get access to the latest security patches, latest bug fixes, latest features. But what if you're not doing an upgrade, right? What if you're doing something like a schema update, right? Or a major version upgrade, or a configuration change? Historically, 2 options. You can do a in-place upgrade, or you can do a switchover. The in-place upgrade is super simple, but you're making a change to your live production system, right? So it's not safe, it's not fast. The other option is you create a staging environment and cut over. Many of our sophisticated customers do this, but it requires a fair degree of sophistication and care, and so it's not simple. So last year, we announced RDS Blue-Green deployments, which gives you a fully managed experience for switchover. And it's simple, fast, and safe. We started with support for MySQL and Maria, and this year, we now support Postgres. And again, tying back to the work we're doing with the Postgres upstream community, a lot of the reason we waited an extra year was that we were not satisfied with the level of logical replication that's available in Postgres. We worked this entire year with the community to make sure that it's up to where we need it to be, where our customers need it to be, and now it's available as part of RDS. Just again, like I said, it's not just for minor version upgrades. You can do any sort of change to your database. And very quick, you start with a blue environment. It's a 1-button click to get to a green environment. We'll seed it. We'll keep it in sync. And when you make your upgrades, whatever changes you want to make, you cut over. Again, it's your 3rd button click, and you're good to go. So that's one on ease of upgrades. The next thing I'd like to talk about is data integration. And why is this relevant and even more relevant now? Amazon provides you a lot of choice, again, in terms of transactional system, analytics, ML services. And going back to what I said earlier, the best way to get more out of your foundational system models is to have your enterprise data make its way into the analytic systems and into the ML models. So really what you're looking for is you're looking to shorten the loop, the learning loop from your transactional systems to your FM models so you can then come back and have outcomes for your customers. Traditional way to do this is ETL, extract, transform, load. So let's say you had an RDS for MySQL database, you have Redshift, you want to get data from one to the other, you build a complicated pipeline, and frankly, it's a lot of work, and it can be fragile. But in many ways, it's overkill for the use case of just getting your data without transformations from your transactional database into the warehouse. So we now support 0 ETL integration between RDS for MySQL and Redshift. And for the simple case where you don't have a ton of transformations going on, it's easy. So first reason we built it, it's easy. Second is it's fast. The replication happens in seconds. And the third is you can use it for more complicated setups where you have many transactional systems all consolidated into one data warehouse. We just make that very simple again for you. So let's go through a little bit of what this is. When you think about 0 ETL, there's really 4 steps. You got to set up, you got to do the initial sync, you got to keep the data in sync, and then any analytics you want to do on the back end. If you're doing this yourself, lots of steps. What we want to do, fewer steps. So we want to get you from weeks or months of work to getting started in minutes. And so how does this actually work, right? So let's go through a few console screenshots. You go to the RDS console, you say you get started, just give the integration a name. You pick your source database. You pick your target database, target warehouse. If you have to configure some IAM policies to make sure that you have the right permissions, go ahead and do that. Then you go add tags, and you're done. Literally in minutes, you can get started. And all the heavy lifting, we take care of under the covers. So what is this heavy lifting? You have your RDS MySQL database. We first have to seed the data into the warehouse. So this is very much like what we do in the blue-green setup. We will go and export the data from RDS onto Redshift. And as part of this export, if you have to do any transformations, we do all those transformations for you. So if you have a data type like varchar, which is on both sides, hey, no biggie, just go ship the data. But if it's something else that has a slightly different form in Redshift, we go do all those transformations for you. So once you've seeded your data, the next step is staying in sync. So we have a CDC stream that we manage under the covers. And essentially, what we're doing is we're getting deltas on your RDS for MySQL side, and we're shipping them over to Redshift. And again, we've done all the heavy lifting to make sure that over 80 plus DML and DDL, so modification of the data and modification of schema types, we take care of all the translation for you, so you don't have to do anything of it. And we do it in a way that's transactionally safe, so you can be assured that the data you see in Redshift is transactionally consistent. And we also do it in a way that it's resilient, because sometimes databases fail, or you may want to change it, a configuration in your database. You may want to upgrade your database, change your instance type. Any of these changes, we make sure that the pipeline stays alive, in the sense that even if we need to reseed the data, we do it for you. So again, a lot of what we're focused on is just click those 3 buttons, and then you're good to go. And so just as summary, it's secure, it's correct, it's resilient, and efficient and performant. The replication is literally seconds from RDS for MySQL to Redshift. And again, as I mentioned before, you can have multiple integrations which all have different sources, but all target the same Redshift data warehouse for data consolidation and analytics use case. And the last thing is, while we take care of all of this for you, we also expose the monitoring metrics so you can be sure that the replica lag is not too long, and you can just make sure that you have peace of mind on how this thing works. The last thing I want to cover in terms of ease of administration is around observability. We offload a lot of the undifferentiated heavy lifting for you, but at the same time, you're running applications on the database, and you want to make sure that you know what your application performance is like, right? And so we offer something called Performance Insights. It's a feature we have offered for years, and customers love it. But one feedback we received is, hey, the observability experience for RDS is fairly fragmented, because your data could be in PI, Performance Insights. It could be in something called Enhanced Monitoring, which is more OS-level metrics. Or frankly, if you look in the whole stack, it could also be in CloudWatch, right? Something about your application. So we heard your feedback, we acted on it, and now it's a single pane of glass integrated with CloudWatch. And so you can correlate changes happening in your app with your database. You can configure your dashboard as you see fit. So again, thank you for the feedback. Keep feedback coming. When we hear it, we will fix it. The other thing that customers said is, observability is great, but do you have any tools that can make troubleshooting faster for us? And so we took, again, your feedback, and we said, OK, let's provide analysis on demand. This is a new feature where you can essentially select a time range. And when you select the time range, what we do then is say, was the database behavior different in this time range than your normal database behavior in a longer time window? So we're looking to see if there's something an outlier. If there's an outlier, the next step that we do under the covers is, why was there an outlier? And then if you know why there was an outlier, the third step is we want to tell you what the recommendations are. And so what could typically take a lot of work on your side, your team's side, to go troubleshoot an issue, again, we want to get from hours down to minutes, but doing as much of the lifting as we can, because frankly, we're sitting on a lot of the data, right? And so we want to make sure that we go from just data to insights. The third thing is, can we go one step further? Because even this is reactive, right? After the issue happened, troubleshoot. Can we proactively tell you what is happening with your database? And so last year, we announced something called DevOps Guru for RDS. It was available for Aurora, and now it's available for RDS for Postgres. And on the console, you can proactively see if there's any issues with any of your databases, in this case, 3, you can click on it, you can see which database is affected, then you can see if it's an ongoing issue, in this case it is. You get the metrics that suggest where the issue is. Again, just like before, we tell you what the root cause is where we know it, and what the mitigation step would be. It's available for RDS for Postgres now. So that was a lot to cover, right? We talked about customer choice, we talked about ease of development, ease of administration, so the main reasons customers use RDS. I want to pivot a little bit and go to the other part of what RDS does, which is to make sure that what you expect in a mission-critical transaction system, you get. So things like availability and durability, performance and scale, and security and compliance. So talking about availability and durability, I'm going to focus on active-active for both RDS for Postgres and RDS for MySQL. So a lot of our customers said, hey, RDS historically runs in an active-passive configuration, right? Even if you have read replicas. What we really need is active-active deployments. And as we start talking to customers, we realize that active-active is an overloaded term. Every customer has a different conceptualization of what they mean when they use the terms active-active. So we dug into it with our customers, and we discovered there were 3 different but related use cases. The first is when you want continuous write availability through host failure. So this is in a single region. I talked about rolling upgrades, which is great, but a rolling upgrade is a planned event. What if you had an unplanned failure? Customers want the ability to keep going without a blip, and one phrase we actually coincidentally heard from multiple customers is no moving parts. They don't want to fail over, they just want to keep writing, and the fewer moving parts, the more likely it'll just keep working. So that's one, that's an in-region setup. Another set of customers have a multi-region ask. It's sort of an extension of what we talked about before. So think about, let's say you're a retailer, you have an inventory setup, and you have 2 sort of inventory systems, one on the West Coast, one on the East Coast of the US. You're simultaneously writing there because you have business occurring simultaneously in both places, but you're probably not touching the same data warehouses, the real warehouses. And so you have very low or no write conflicts. So simultaneous writes, but very few conflicts. And in the case that you do have some catastrophic event, you want to be able to redirect your writes to the other side of the continent, right? So this is the second use case. The third one goes one step further still and says, what if you have a follow the sun model? And these are customers where you may have a global workforce, or you may have a global customer base. And again, your workload patterns tends to follow the sun, and there tends to be very low conflict in terms of overlapping and writing the same data. But just as before, if you have a catastrophic failure, you still want to keep running your business by failing over a different region. So these were the 3 use cases we discovered. And so when you think about active-active, from a technology standpoint, there's a fundamental choice you have to make. Do you want to synchronously replicate between these nodes, or do you want to have asynchronous replication? And it's a trade-off between latency and conflicts. If you have synchronous replication, you avoid conflicts because all your nodes are saying the same thing at all times. And this makes application development very simple, right? It's kind of like the same as writing to one node. But you do pay the cost of round-trip latency. If you have async replication, it's the reverse. Your application has to be aware of semantics. Hey, I thought something was done, but I may have to undo it, right? Or if you have a catastrophic failure, you may actually lose some of your data because asynchronous replication, by definition, the other side doesn't have all of the data. So in addition to this choice that you have to make as a builder, I also want to highlight that failure handling in active-active scenarios can be tricky, right? You don't want to be trigger happy, because if you fail over and you realize it was just an intermittent failure or gray failure, there's a lot of work to go fail over across nodes or across regions. And you also want to be able to do things like failback. So this requires a fair degree of sophistication to be able to write applications that work well in an active-active deployment. But many of our customers do this today. Many of our customers have active-active setups, and they self-manage it. And the ask for RDS was, we get that this requires a degree of sophistication, but we know how to do this. What we don't want to do is all the other stuff that RDS already offloads to our other databases, like backups and patching. So can you make this capability available in RDS? And we understand that as application developers, we also have to have a shared responsibility in making sure that the application works correctly. And so for these customers, we now support active-active deployments with an extension called PG Active for Postgres and MySQL's group replication. So the PG Active extension is derived from BDR v2, which is an open source extension. We made some changes to it to improve its performance and accuracy. And MySQL is based on a community plugin. PG Active uses async replication by default and last update wins. And the latter is a synchronous solution. And they're available for Postgres and MySQL respectively. So very easy to get started. So in the case of PG Active, you create a parameter group, a database parameter group, and you enable PG Active. When you create a new instance or you modify an existing instance, you associate it with PG Active, with this parameter group. Then installing PG Active is just a create extension statement, just like you'd create any other extension in Postgres. And then on the first endpoint, you set up all the connection information about the entire cluster, and you initialize the replication. Then you do the same thing, steps 3 and 4, on the other parts of the cluster, and then you join the replication group, and that's it. There are limitations you should be aware of. I won't go into detail on this, but I'd encourage you to read our blogs or documentation for this. Things like DDLs and large objects are not replicated. Right? And on the MySQL side, again, with group replication, very similar workflow. You create the parameter group, you provision an instance with a parameter group, you configure the replication, and then you get going. And again, on the MySQL side, we have learned a lot of best practices talking to our customers. So again, I'd encourage you to read the documentation and our blog posts on this. An example would be make sure that your transaction size is not too large. So that is on availability and durability. The next area is around performance and scale. As I mentioned, this matters because we want to make sure that we're raising the ceiling and keep giving you headroom as your business grows and your workloads grow. And the second is that we want to keep delivering price performance improvements so you can get more with less with RDS every single year. And so to this end, we are always supporting the latest instances from EC2. You can see some of the instances that we have launched for the open source databases. I'd particularly call out the newest version of Graviton, offers you plus 27% in price performance. I'd also call out the N instances. N is for networking, high throughput networking. It is particularly valuable in a multi-AZ setup when you're communicating across AZs and also when you have network storage, which we do in RDS. So that was on the compute side, and really our strategy is to make sure that we offer you the best instances that are available on EC2 that are relevant to database workloads. This year, we also took on an effort to make our storage performance better and more stable. We don't often talk about storage, so I'm going to explain a little bit more detail than otherwise. So the way RDS storage works, you have the compute instance, which is that chip icon, and under the covers, you have between 1 and 4 volumes of network storage. The data is striped and mirrored across the storage, and each of these volumes are using reliable disks. So this is in one AZ, right? So if you have a multi-AZ system, in classic instances, you'd have 2 sets, so you'd have between 2 and 8 volumes. If you use the multi-AZ database cluster, you'd have between 3 and 12 volumes. Between these AZs, we also synchronously replicate the data, right? And the thing that is important to note here is that each of these volumes has both the transaction log records, it also has the data pages. Now, why am I saying all of this, right? Transaction log records have different performance needs than your data pages. Transaction log records, the writing of it, is in your transaction commit path. You want it to be blazing fast. The data page flushes from your buffer pool can happen asynchronously. And so when we have as many volumes as we do, and why do we have so many volumes? It gives you more IOPS, by the way. It's additive. But when you have as many volumes as we do, and when they're synchronously replicated, and when you're co-locating your transaction logs with your data pages, a couple of things happen. You have contention for resources between the transaction logs and the data pages. That's one. And the second is that if you have any jitter, I/O jitter, latency in any one of these volumes, it starts cascading and backs up into the database, and databases typically don't do well with jitter, right? It ends up backing up into your data application. So customers asked us to fix this, and the way we are fixing this is through this new feature called dedicated log volumes. And essentially what we do under the hood is we take all the transaction logs and we place it in its own network storage volume, separate from the data pages. And so what does this give us? First, logs are written sequentially, so you get better performance because you can do I/O merge. You also are not contending for resources, so that also gives you slightly improved performance. And then because the logs are not spread across as many machines under the covers, you have lower probability of encountering jitter. And so you get better performance and more stable performance at the database level, which is crucial for your apps. It's available again for the Postgres engines, and we plan to also continue supporting it for the other engines. So here's just a quick example. We ran PG Bench. The concurrency level was 64, and we ran it for a full week with about 1,000 TPS. We used data volumes for 20K IOPS, and the dedicated log volume was only 3K IOPS. So the orange lines that you see here are for the baseline. And in fact, you cannot see the dedicated log volume at all because of how effective it is. So what this shows you is the number of outliers greater than 50 milliseconds we saw over that week-long period. And it's a histogram, so when you go to the right, it's even bigger outliers. And we saw about 1,441 outliers at the 50 millisecond level. But with dedicated log volumes, it came down to just 1. So we buffered most of these outliers from the database and from the application. And then when you look at a more rigorous threshold of 20 milliseconds, the number of outliers were slightly north of 2,000 in the base storage, but only 3 of these manifested in the application. And 2 were under 50 milliseconds, and 1 was above. So that's on more consistent performance. So we've talked about improvements we make in the compute area, which is frankly just following EC2. We've talked about an improvement we made in the storage, but we also do work to optimize the entire stack. So last year, we introduced 2 new features, one called Optimize Writes, the other one called Optimize Reads. And essentially, they double your write and read performance respectively. And let me talk through Optimize Writes first as a quick recap. So in the case of MySQL, it uses 16 kilobyte pages. And historically, what we have been able to write to storage, persistent storage, is with 4K atomicity. So your 16K page, when it gets flushed to persistent storage, gets written in 4K chunks, four times. And what happens is that, let's say that you have some sort of a failure after you write 2 out of the 4, you have what's called a torn page. So if you have a crash and your database recovers, you don't actually know whether you have a consistent 16K page. So the way MySQL solves this traditionally is you have something called a double write buffer. You write the storage twice, and then what you're doing is you're verifying that both copies are the same. So it works, it's durable, but then you're writing twice, right? And you're paying that penalty. With EC2 Nitro instances, we can now write with 16K atomicity. So you don't need that extra storage. You can do away with it, and you're effectively doubling write performance. Last year, we supported MySQL. This year, we've added support for MariaDB. That's on the right side. On the read side, again, we have our persistent storage on network storage. And when you do a read, let's say you're doing a large join or sort, or you have a common table expression, you end up creating temporary files which don't need to persist through failure. Like if you're running a join and you have this temp table, or you have a temp table, and your database crashes, when it comes back up, you basically wipe all of that out anyway for consistency. So there's no reason to fetch that all the way from network persistent storage. You can actually place them on local instance storage right next to your processor, right? So with D instances, you can put temp storage on any temp object on the compute instance itself, and you essentially get 2x faster queries. So last year, we added support for MySQL and MariaDB, and this year, we have added support for Postgres. So again, if you run a HammerDB benchmark, whether it's a TPCC-style benchmark for writes or a TPCH-style benchmark for analytics, in both cases, we have seen up to 2x performance improvement. And then this is not quite a feature. It's maybe a look under the hood of what we do. We're continuously working on optimizing our stack, even in cases where it doesn't manifest as a feature to you, right? So you may not see it in a what's new launch, but it ends up being something that benefits you when you upgrade to the latest version. And these come from 2 types. One is changes in the community database or the third-party database itself. And so in the case of MySQL, they introduced a new system called fdatasync instead of fsync, which is more efficient in terms of flushing data to disk. And then across both RDS for MySQL and MariaDB, we updated our tool chain, right? New compression library, new GCC. And effectively what happens when you use RDS MySQL 8.0.35, you get up to a 3x higher write throughput versus older minor versions, both on the basis of the community change, but also the changes we've made internally. And in the case of MariaDB 10.11, you see a 40% increase in transaction throughput, again, just based on the improvements we've made under the covers. So that's on security and compliance, performance and availability. And last but not the least is security and compliance. So if you ask any Amazonian what their job is, they'd say, my job number one is security. So all Amazonians obsess over keeping your data secure. It is our job number one. And so a lot of what we do from an engineering standpoint is under the covers, we're hardening the systems, keeping you safe. And it never manifests again as a feature, right? And so while we don't talk a lot about it, it is a big part of what we do under the covers. That said, there are some times when we do announce features that are directly visible to you. So I'll talk through a couple quickly, but this is only a small sliver of all the work we do in terms of security and compliance on behalf of our customers. Both of these happen to be in the SQL Server space, and they're just a highlight, not a complete list. The first is database activity streams. Essentially what this lets you do is it audits any event in your database, like invalid login attempts. And you can export it using Kinesis into OpenSearch, Redshift, so you can analyze it, right? So it's a good audit mechanism for you. And the other one is self-managed Active Directory. A lot of customers who use SQL Server use Active Directory either because they're required to, or it gives them the permissioning that they need, and it's now available for RDS for SQL Server. So we've talked about a number of different types of innovations. We started with customer choice. We talked about simplicity, both for developers and administrators. And then we also talked about some of the core value propositions around availability, durability, performance, scale, security, and compliance. So when you look at the long arc of RDS, we have innovated on all these dimensions over the last many years. As you can see from the list, our rate of innovation is accelerating. And I hope that you find value in this innovation. As I mentioned earlier, 90% of our roadmap really comes from conversations with customers. We work backwards. And so keep the feedback coming. Let us know what would be valuable for you. And next re:Invent, I hope to have another set of exciting announcements for you. Thank you, everyone.